So what we are going to do now is just work a few example problems to try to get our feet wet with using voltage division. So let's start with the simple circuit that we have on the left, okay? So we have a 12 volt source connected to an 8 ohm resistor that's in series with a 7 ohm resistor that is in series with a 5 ohm resistor. Applying voltage division, we can find that the voltage Vx, the voltage drop over the 7 ohm resistor, is simply Vx is equal to our source voltage, 12 volts, multiplied by the resistance we want the voltage drop over, 7 ohms, divided by the total series resistance, which in this case is 8 ohms, plus 7 ohms, plus 5 ohms. We can simplify this. 12 volts times 7 ohms over 20 ohms. And let's see, so this is going to be 12 times 7, which is 84 divided by 20. Which looks like 4.2 volts, if my mental math is correct. For the next example, we have a very similar situation. However, the polarity on the voltage drop that we want is flipped. Okay? Now, when we defined voltage division, we saw that the voltage drop of all of the resistors were opposite polarity to the one that we saw for our voltage source as we followed the current around the path. This time, the voltage drop has the same polarity as we follow our current clockwise around the loop. So what's going to happen is we're going to have to include an extra negative sign, and the reason being is that we know for sure that the resistor has to be absorbing power, which means we are effectively considering the current is flowing in the opposite direction as to the one that we know it's flowing. So in this case, Vx is going to be negative 18 volts multiplied by 9 ohms, the resistor we want the voltage drop over, divided by 4 ohms plus 9 ohms plus 2 ohms, which looks like negative 18 volts times 9 over 4 plus 9 is 13 plus 2 is 15. And let's see, 18 times 9 is 81 times 2 is 162. I can't simplify that anymore in my head. All right, moving on to our last example. We have a bit of a conundrum here because voltage division only works when we have resistors connected in series. So that may lead you to think that the voltage Vx could be 10 volts times, we want the voltage drop over the 6 ohm resistor, so 6 ohms, and then we have the 7 ohm resistor and the 6 ohm resistor. But this is not correct, okay? The reason that it's not correct is because the 6 ohm resistor is not in series with the 7 ohm resistor, okay? They are not in series because there is another path that branches off, so they don't have a single point of interconnection with no branching paths. Instead, what we can do to apply voltage division is treat these two resistances, the 6 ohm resistor and the 3 ohm resistor, as a single equivalent resistance because they're connected in parallel, and then use voltage division to find the drop over that equivalent resistance. So in this case, that looks like, let's see, so 6 ohms in parallel with 3 ohms is the resistance we want. So that's going to be 6 times 3, 6 ohms times 3 ohms, divided by 6 ohms plus 3 ohms. This whole thing is going to be divided by the total series resistance, which is our 7 ohm resistor in series with this parallel equivalent resistance of 6 ohms times 3 ohms divided by 6 ohms plus 3 ohms. And so now we're going to need to do a little bit of simplification. We're going to have 10 volts. Our numerator here, 6 times 3 is 18, divided by 6 plus 3, which is 9, so 18 over 9, 2 ohms, divided by 7 ohms plus 2 ohms, gives us 10 times 2 over 9, 20 over 9 volts.